This is Mr. Beck Does Your Homework, AP Physics, Homework 7.3, question number 2. A constriction in a pipe reduces its diameter from 7.1 centimeters to 1.6 centimeters. Where the pipe is wider, the fluid velocity is 8 meters per second. Find the fluid velocity where the pipe is narrow. This is using my continuity of flow equation, which tells me that my initial area times my initial velocity is going to be my area later times my velocity later. So I don't have area, I have diameters, and it's in centimeters, so, but I am given a velocity. What I'm looking for is my velocity where the pipe is narrow. So where the pipe is wider is where it starts. The fluid velocity is 8 meters per second. So I'm looking for this new velocity where it's narrower. So my area where it's wider is going to be pi times the diameter they give me divided by 2. And that squared. Now it's also in centimeters, so I could divide also by 100 to get 0.071, but there's something neat that happens here, because if I do that times my initial velocity is going to be my area 2, which is pi times, so this is d1, this is going to be pi times d2 over 2 squared equals my velocity 2. And I know that my diameter also has a, divided by 100 necessary in there. But let's take a look at this. I've got pi on this side and pi on this side, so those are going to cancel. I've got a divided by 2 squared and a divided by 2 squared on that side, so those actually can go away. And this is going to have a divided by 100, and this is going to have a divided by 100, but those are on both sides, so that can go away. So what it turns out is that my diameter 1 squared times my velocity 1 is going to be my diameter 2 squared times my velocity 2. And I don't even have to convert into meters. It might be helpful to do that, and just to be sure, because maybe later you'll need the area, but looking at this logic, it seems pretty obvious that that's all going to go away. So if I want my new velocity, it's going to be my diameter 1 squared times my velocity 1 divided by my diameter 2 squared. So you can get your velocity that way, where the pipe is narrow.